Okay, we're going to start working through this table now. The first structure we want to find is hydrochloric acid, or hydrogen chloride rather. And so, we bring out a piece of paper and we'll work through this. The Lewis structure for HCl. So part 1, number of valence electrons. Hydrogen and chlorine make up this molecule. Hydrogen is row 1 and is on the first it's column 1 rather, and row 1. So it's on the first row here, so it only has a duet rule rather than an octet. And since it's on row 1, it only brings 1 valence electron. Since chlorine is on row 7, we know that it has 7 valence electrons. And now we need to figure out what the central atom is. In this case, it doesn't necessarily matter, but theoretically the central atom, I mean, there's really not one because there's just two atoms, right? So now we'll assign electrons by drawing H and just bonding it with Cl. This has used 2 valence electrons like this. We have 6 valence electrons left. We'll check the octet or duet rule. So this bond counts for 2 electrons. So hydrogen is satisfied, its duet rule is met, but chlorine needs an octet rule, so we need to assign the rest of these valence electrons. Since hydrogen is satisfied, we don't have to add any more electrons to it. So all the electrons will go straight over to chlorine. So 1, 2, 3, 4, 5, 6, 7, 8. We've used all 8 valence electrons. There are no valence electrons left. We'll check our octet and duet rules. Hydrogen's still satisfied with its duet, and now chlorine also has 2, 4, 6, 8. Its octet rule is satisfied, and now we can build this model. Okay, so I'm on a new sheet of paper here. We're going to build the model of this. We have a hydrogen that is bonded to a single bonded to a chlorine. It's a pretty simple model. And that's it. There's really not much more to say about this. It is going to be a linear molecule just because these are 180 degrees apart from each other.